Welcome back to eCoreAcademy, students. My name is Anita and I am one of the teachers and co-founders here, along with my younger brother AJ. As you can see, I have a new Algebra 2 lesson prepared for all of you. In this, we'll be taking the next step in our quadratics unit through the lenses of a higher level math student. Today, we're going to be looking at the quadratic formula, and this will be part 1. Hopefully you remember the quadratic formula from Algebra 1, but like I say with all these quadratic topics, if you don't remember it, that's perfectly fine. That's the whole point of today's lesson. So today we're just going to be refreshing on what the quadratic formula is. Probably when you were in Algebra 1, if you do remember being taught the quadratic formula, your teacher just threw a formula at you. No offense to your teachers, but they probably just gave you a formula and you were told to memorize it and apply it when you ran into situations where your quadratic equation was not factorable and completing the square just didn't work because your b term may have been an odd number or something like that, where just those two methods didn't work the best. So your teacher was like, then your last resort would be the quadratic formula. However, now, because we're higher level math students, because we're in Algebra 2, we're going to be looking into how this quadratic formula works. How is it derived? That's the first question we're going to be asking. Where do we get this formula from? So a formula is pretty much just this literal equation. So a literal equation has a bunch of variables. Variables can be letters of the alphabet that represent different numbers. And then depending on the quadratic equation you have, you would plug in those corresponding values so that you can solve the quadratic formula. So we're going to be looking at how it's derived, and then we'll do one easy practice problem together just so you get used to how to plug values into the quadratic formula and solve using the quadratic formula. So remember, we use the quadratic formula when factoring and completing the square do not work. Notice how I put this in parentheses because there's always a way to figure something out. If it's not factorable, most of the time completing the square will work. But let's say you don't want to do those because you're on an assessment and it's being timed and you want to do something as fast as possible. And let's say completing the square is just not a method that's fast for you, then your next resort would be the quadratic formula. So that's why I wrote do not work. So we're looking at 3 methods to solving quadratic equations: factoring, completing the square, and now today the quadratic formula. Before I even get into the video, I would really appreciate it if you all hit the like button, hit the subscribe button, hit the post notification bell, dropped a comment down below, and shared using our socials. It's all very much appreciated. Okay, so let's get right into what is the quadratic formula. So the quadratic formula is a formula derived by completing the square, and it can be used to solve any quadratic equation. So remember, by completing the square, we are trying to move our c value to the right side of the equation, and we're trying to force a perfect square trinomial on the left side of the equation so that we can square root, but we can take the roots of both sides of the equation, and we can actually solve for x. Usually you use this when the quadratic equation you've originally been given, you can't GCF, you can't perfectly GCF something out of it, or it's not factorable, one of those scenarios. So that's where you would use completing the square. So quadratic formula is a formula derived from those mathematicians who came up with completing the square. They took it a step further and they were like, let's develop the quadratic formula. So that's where the quadratic formula came from. And unlike factoring and completing the square, the quadratic formula can be used to solve any quadratic equation. So even if you're given a simple quadratic equation, like I'm going to give you an example, x squared plus 2x plus 1 equals 0. Even if you're given something simple like that, that can be factored. It's a perfect square trinomial, but you can always use a quadratic formula. The quadratic formula works with anything. So usually you use the quadratic formula in the following circumstances: when either your quadratic equation cannot be factored and you cannot GCF so that a is equal to 1. So it can't be factored, meaning you can't break it down into its factors. Then you would think, let me go to completing the square. Well, what happens if you can't neatly divide out whatever your a value is, and then you end up getting a b value and a c value that are both fractions, and you don't want to work with that because then you're squaring those values and it just turns into a mess. Especially if you're not good with fractions, I would highly suggest avoiding that. So that means you can't GCF, so a is equal to 1. In this case, if you can't GCF, in your case, a is not going to be equal to 1. And our whole goal of completing the square is moving our c term to the right side of the equation. And before we even do that, we GCF, so we make the a value equal to 1. So immediately, if you rule those two out, then you have to go to the quadratic formula. So the quadratic formula directly solves for x by using the a, b, and c values of your quadratic equation. So it directly solves for x. What does that mean? So if you have the quadratic formula, if it directly solves for x, it looks something like this. I'm going to show you what the quadratic formula is in a second, but when it directly solves for x, it's literally you're just plugging values in, and whatever answer or answers you get, that is what x is equal to. You don't need to do any further work. It's just x is equal to this and this, or just depends on how many solutions you'll have. Typically, you'll have two because with quadratic equations, we have two solutions, but I'm just saying it directly solves for x. Let's leave it there. And it does this by using the a, b, and c values of your quadratic equation. So what does this mean? So remember, quadratic equations are ax squared plus bx plus c. So if you look at the literal equation, which is your quadratic formula, you're gonna see that you're gonna see a, b, and c used in that. So whatever your a, b, and c values are very crucial because you're plugging them into the formula to find out what your x is. So that's why you're plugging these three values in. You're plugging a, b, and c into your quadratic equation. And remember, your quadratic equation should be in standard form for this to work. If it's in vertex form, you're going to have to convert it and so forth. It needs to be in standard form because you need those specific a, b, and c values to plug in. And lastly, here is what the quadratic formula looks like. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and all of that divided by 2 times a. I know it looks like a lot, and I understand if at first it's hard to wrap your head around it, but eventually you're going to have to memorize this. And you're going to have to memorize it because if you're taking an assessment, you don't get to use reference sheets, especially in Algebra 2. And it's not like your teacher is going to write the quadratic formula on your test for you to refer to when you're doing these problems. So what I would suggest is you memorize this, and if you do go to take an assessment, or even if you're practicing on your homework or anything your teacher's assigned, I would suggest writing the quadratic formula in the top right corner as soon as you get your test paper so that you can always refer back to it. So if you just vomit it onto the paper right then and there, you don't have to refer back to that every single time you do a problem. You'll just be able to flip the page back to the first page and it'll be written right there for you to refer back to. So you're going to have to memorize this, but if you look at it right now and you don't have it memorized, that's perfectly fine. Just practice with it. Okay, so the next question is, how do we derive it? So remember how I was saying that as an Algebra 1 student, you're probably given this equation. Your teacher didn't really explain how you got this, you were given this formula. Your teacher didn't really explain how you were given this formula, but you just used it. However, now I'm going to show you exactly how we derive it. And how do we derive it? So we're deriving it from standard form. And remember, standard form is ax squared plus bx plus c, and this is equal to 0. As you can see, you're solving for x. Remember, what does that mean? Solving for x. So you're trying to move your a, your b, your c, all your other values and everything else to the right side of the equation so that ax squared plus bx plus c equals 0 then becomes x equals something, and that something is in terms of a, b, and c. So you're solving for x, and remember, you're going to start off with this equal to 0, but it's gonna change. So it's going to be equal to a, b. X is going to be written in terms of a, b, and c. So here is the solution pre-written for you. This is exactly how I did it in class and how my teacher showed me. If you want to copy that down, feel free to do so, but I'm going to go through it with you again. So if you want to pause the video and copy that down, feel free to do so. Okay, hopefully that was enough time for you to copy that down if you wanted to. Now we're going to be doing this together. Okay, so first, let's start off by writing our standard form. So remember, this is being derived from standard form. So we're going somehow from standard form to the quadratic formula. Our standard form is like our basis when we are solving quadratic equations. So ax squared plus bx plus c. Now let's try to, and remember how I said on the last slide that quadratic formula incorporates completing the square. So I'm just going to put an asterisk up here and say complete the square. So it involves that. And I'll show you exactly what I mean, because what we're actually going to do is we are going to be following the steps of completing the square to derive the quadratic formula. So what do I mean by this? So our first step is going to be divide all of these values by a. So if we divide all of these values by a, ax squared divided by a is equal to just x squared because the a's cancel out. bx divided by a is just equal to b over a times x, and then c divided by a is just c over a, and just 0 divided by a is equal to 0. So we get there. Okay, so now what we're going to do is we're going to subtract our c value from both sides. So if we subtract the c value, we get x squared plus b over a times x, and we subtract our c value, we get negative c over a. Afterwards, what we're going to do is we are going to find our b over 2 squared using this b value. So remember b over 2 squared. So we're just going to plug this in. B over a is going to be plugged in for b. So just watch how I do this. So we're going to have b divided by a. We're going to have, and then that is going to be divided by 2. So it looks kind of like a complex fraction. B divided by a divided by 2 is just b over a times 1/2. So 2 would go to the denominator, and we would end up getting b over 2a. And we are squaring that. And this will be equal to, well, b squared is b squared. And then if we square the denominator, 2 squared is 4, and a squared is just a squared. So that is our b over 2 squared term that we're going to be adding to both sides so we can force that perfect square trinomial. So let's add that to both sides. If we do that, we'll get x squared plus b over a x plus b squared over 4a squared equals negative c over a. And remember to add the b squared over 4a squared to both sides of the equation. And then we will get that. So that's how we got up to there. So now what we have to do is let's break this perfect square trinomial down into its factors. So what does its factors look like? I'm going to move the work up to this side of the screen. So if we write this out, remember, to break this down into its factors, because remember, perfect square trinomials, in this case, it's going to be equal to a plus b times a plus b. That is how we break down the perfect square trinomial. In this case, if we do b over a divided by 2, just ignore that square root, because remember, when we're writing it as a factor, we're just dividing it by 2. Then we'll get this b over 2a value. That's what we're going to be adding. So x plus b over 2a, and that quantity squared will give you the perfect square trinomial that we have right here. So that squared is equal to negative c over a plus b, whoops, I forgot to write the b squared here, b squared over 4a squared. So then what we have to do is we have to somehow combine these. So how are we going to combine these two fractions? Well, we got to find a common denominator. So in order to find that common denominator, we have to multiply the numerator, which is c, by 4, and we also have to multiply that by a. So in order to do that, we have to make the denominator similar. Therefore, we have to multiply this single a right here by 4. We also have to multiply it by a, and then we'll get 4a squared. So therefore, if we do the denominators, we will end up getting 4a squared. And if we multiply the top by 4a as well, we get negative 4ac. And to that, we are adding this b squared over 4a squared. Then if we just continue our work, we get x plus b over 2a squared is equal to negative 4b squared. So we're going to rewrite this as, because the b squared is positive, we're going to rewrite this as b squared minus 4ac, because remember, we are going to be combining these numerators because the denominators are both, we have common denominators. Now we're going to put it all over the common denominator. And then afterwards, we want to square root both sides to get rid of the square root right here. So we end up getting x plus b over 2a. And if we square root the top, we'll just get the positive or negative square root of this whole thing right here. So I'm just going to copy that down. B squared minus 4ac. And then we get that over the square root of the denominator. We need to square root the denominator as well, which is 4a squared. And then lastly, I'm going to combine two steps in one. So this right here, this whole expression b squared minus 4ac, this is going to stay in this radical because we can't really separate this. But however, if you look at the denominator, 4 is a perfect square and a squared is a perfect square. So the square root of 4a squared is 2a. 2a times 2a is equal to 4a squared. Therefore, we're going to subtract, if this becomes 2a, then that means this b over 2a on the left-hand side of the equation has a common denominator with whatever's on the right-hand side of the equation. So I'm going to subtract b from both sides. I'm going to get negative b. So we just got rid of this right here. And then I'm going to have that plus or minus the square root of b squared minus 4ac, which I just had in that radical. And that's going to be over 2a because 4a squared and the square root of 4a squared is 2a. And this, folks, is how we derive the quadratic formula from standard form. I know that was a lot of work and it was kind of a messy process, and it's totally fine if you don't really understand how we got there. I would suggest looking through it more and just going through it and seeing. Remember, at the end of the day, we were trying to solve for x. That was the whole point of this, solving for x, so that we can get a formula that directly leads us to x using a, b, and c from standard form. So just look over that after you watch the video, and trust me, you'll get it if you really try to understand the work that we just did and how we also applied completing the square. Okay, so now we're going to be doing a problem together, a practice problem, so that we can just apply the quadratic formula. It's not going to be too hard because we're not going to be deriving anything. Probably deriving the quadratic equation was the hardest thing you'll see, and that won't be on any. I can't promise that it won't be on any assessments, but I have personally never seen it on an assessment before because it's just really enrichment based off of the fundamentals you learned in class. It's almost like that student in class who's like, okay, but how do we get this? Questioning everything. So that was the whole point of doing the deriving the quadratic formula. So don't worry about it for any assessments, but I would highly suggest that you try to understand how we got there so you understand the properties of the quadratic formula. So you're not just memorizing a random formula, you really don't understand how you got there. I would suggest just going over that. But for this problem, we're just going to be given a quadratic equation, and we're going to be asked to solve the following by using the quadratic formula. As you can see in this equation, we can't factor it, and also we can't GCF, so a is equal to 1. In this case, a is equal to 8, but 14 and 15 are not divisible by 8, so we get an integer value. So we don't really want to work with fractions, so we can just directly go to the quadratic formula, and it'll be a less messy process. So here's the solution already pre-written for you. Of course, I'm going to be going through this again, but if you want to copy this down, please feel free to go ahead and do so. Okay, hopefully that was enough time. So now let's actually do this together. So first, let's begin by writing this quadratic equation that we have been given. So we've been given 8x squared plus 14x minus 15 equals 0. So right underneath that, I want to rewrite the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And if you're starting off with these practice problems, I highly recommend you rewrite this. It might seem redundant, but actually by rewriting it, by muscle memory, and by looking at it multiple times, it'll be easier for you to memorize for your assessment. So I highly suggest you do that when you first start off using the quadratic formula. So now we know that our a value is 8, we know our b value is 14, and we know our c value is negative 15. Pay attention to this negative sign right here. And what we're going to be doing is plugging our a value wherever a is in the quadratic formula, our b value wherever b is into the formula, and our c value wherever c is in the quadratic formula. So we're going to be writing that out. So x is equal to negative b. Well, b is equal to 14, and negative b is negative 14. Plus or minus. I also want to go over why we have plus or minus. We're taking the square root of a literal equation like this. We can have a positive or negative root. So let's say this, whatever is in here, is equal to 25. Well, we can have the positive or principal root, which would be 5, or the negative root, which could be negative 5. Remember, with quadratics, we typically tend to have two solutions. That's not going to be the case in all situations, and we'll be seeing why in two videos that I make. But I just pay attention to this positive or negative sign. And as we get closer to the solution of this problem, you'll understand why. So plus or minus the square root of, b squared. B squared is just 14, because remember 14 is positive. 14 squared minus 4 times a, our a value is 8, and our b value is c. So that would be that this whole thing totally expanded out. And then that would all be over 2 times a. So 2 times 8. Afterwards, we're going to try to simplify what's in the radical first. You always want to look into simplifying this. So I'm just going to rewrite it. X is equal to negative 14 plus r minus, 14 squared is equal to 169. And it's okay because we're going to be dealing with big numbers right now. So if you want to pull out a calculator, you can, but I have the solution next to me. So I'm just going to be telling you what these are equal to. Really, the multiplication, understanding how to multiply numbers is not the whole purpose here, but you should be able to do these. Like if you had scratch paper off to the side, you can just write them down, or if you have a calculator, it really doesn't matter. Just know that on an assessment you might not have access to a calculator, so be able to multiply these numbers out. So if we multiply negative 4 times 8, we get negative 32, and negative 32 times negative 15 gets us to 480, positive 480, because especially with this negative 4ac minus 4ac part, you need to be conscious of sign changes. So negative times negative is positive, so we end up getting plus 480. And then that will be over 2 times 8, which is 16. So this is how we just simplified everything in the radical, and we broke it down into our b squared, whatever b squared is equal to, and then whatever minus 4ac is equal to. Afterwards, we're just going to keep solving this. So x is equal to negative 14 plus or minus. So let's figure out what this value is in the radical. So 169 plus 480 is equal to 676. So the square root of 676 over 16. So x is equal to negative 14 plus or minus, the square root of 676, I'll just tell you right now, is 26. So luckily it comes out to a neat integer value for, I should have written square root, but the square root of 676 comes out to a neat integer value because this is a perfect square. It's 26. 26 times 26 is 676. So we're going to have plus or minus 26. We can get rid of that square root symbol because we've already square rooted 676. That will be over 16. So now what do we do? Well, we can't leave it like this because right now we have integer values. If we had a radical over here, meaning that whatever was in our radical sign up here was not a perfect square, if for some reason this was not a perfect square, we would probably have a different scenario. But because this was a perfect square, we were able to get the integer 26 out of it. Now there's a different approach that we have to take. So what is that different approach? Well, we can either have x equal to negative 14 plus 26 divided by 16, or we can have negative 14 minus 26 over 16. Because remember, 26 can be positive or negative, because positive 26 times positive 26 is 676, and negative 26 times negative 26 is also equal to 676. So you must remember to take both of those into account. That is why we have this plus or minus symbol right here. So we have two different solutions that we have to solve for. Therefore, I'm just going to branch them out this way. So x is equal to negative 14 plus 26 over 16, which means x is equal to, negative 14 plus 26 is equal to 12, and over 16. So x is equal, and we just simplify that to 3/4. There's also another solution. What if 26 is negative? So x is equal to negative 14 minus 26 over 16. So that's the sign change. Negative 14 minus 26 is negative 40 over 16. And if we simplify that, we get, if we divide both the top and bottom by 8, we get negative 5 over 2. So you can just leave that like that. Therefore, our solutions are going to be, I'm just going to write it down here, x can be equal to 3/4, or x can be equal to negative 5 over 2, and it will satisfy this quadratic equation. And we just got that by using the quadratic formula. So that was the problem. We just used quadratic formula to solve that. So that is all I have for you today. I hope you enjoyed the video. If you did, I would really appreciate it if you liked, subscribed, hit the post notification button, drop a comment down below, and share using our socials. Our socials are Facebook, Twitter, and Instagram, and you can find them all in the description box below. If you have any personal or business correspondences that you would rather reach out to us personally, please email us at eCoreAcademy@gmail.com. Lastly, we have a website going out soon, so please look out on our social media platforms so that we can notify you of when that comes out. It's going to be such an advantage for all of you students who use it to get ahead in class. Again, that's all I have for you today. I hope you enjoyed the video. Please look out for the quadratic formula part 2. We're going to be working through an application together, so a word problem, special word problem for all our students. Have a nice day. I'll see you next time. Bye.